Hi TechOne. For my session today, I'd like to talk about the internals of Git. And my goal for today is for you to grasp some of the core concepts of how Git works from the inside out. And to be able to learn about this, it might actually be a good idea to have some basic knowledge of how Git works. So maybe you have experience with some other version control system, that can help as well. And even if none of this actually applies to you, I hope you can still find it useful. Anyway, let's get started. So what is Git really? And Git is in essence just a database of references of blobs. So in this case, we have the Git directory structure. And that is what you will get when you run git init, the initialization command. And Git contains this data structure and heap of objects in your repository. And that will actually keep track of your entire state of that repository. Now Git also contains a bunch of tooling around this to be able to manipulate these objects, shuffle them around, create them, read them. And I will explain a bit more into depth how this actually works later. I think first we need to grasp some of the core concepts of Git. So Git will contain 3 core object types, and everything Git does, it does through these object types. And the first one we have is the commit. And the commit object is containing a bunch of metadata. So it will contain, for instance, who is the creator of this commit, who is the author, when was this commit created, like a timestamp. And it will also contain a pointer to the parent commit, and as well as a reference to a tree object. And so you might ask, what is a tree object? And yeah, it's an object that contains pointers to other trees. So that's very helpful. But it also contains some more information. It contains pointers to blobs and file names of those blobs. Okay, so last one. What is a blob? And a blob is the data you care about, the data you create, and the data you want to version control, to handle, to get to help you handle. And a great way, I think this is like a dependency graph here. Let's see. A great way to visualize this is through something like this. So we know that the commit can have a reference to itself because it has this parent commit reference. But it also references a tree. And we learned before that trees can have references to other trees, but also one or more references to blobs. Okay, so that's very cool, but now what? So what do we do with this information? Let's go back to this directory listing here. Let's make some observations. So this is the directory structure you will get when Git is initialized. I've removed some of the default objects Git will create just to give you a bit clearer view for educational purposes. And I think one important thing here to realize is what these things mean. So a cool observation here is, what do you actually get when you combine the directory name, 11 in this case, with the file name, eb61, and so forth? This is actually a SHA-1 hash. And that's interesting because we have information about this object here. All of these files here are objects, actually the Git 3 Git core objects, one of these on disk. So what object is being hashed here? What is the object that creates this hash? And in this case, it's a commit object. And we learned before that the commit object has a couple of metadata information stored in it. So we have the author, the committer, and also the commit message that we use. In this case, it's the second commit. Maybe not the best commit message, but you know, for educational purposes. And then we also have a parent reference. So that's a pointer to the commit that came before this commit. And in this case, it's probably the first commit, since this is the second. And we also have this tree reference here. And I think an observation here as well is, yes, that's a SHA-1. And yes, that's also present in the Git directory structure. We can find it here. And the object being hashed is a tree object. And we learned before that tree objects, they can reference other trees and blobs. And in this case, it's just one blob. And yeah, that's a SHA-1 hash as well. So we can actually go down the rabbit hole here and see, yes, that also exists in the Git directory structure. Let's try to see what object's being hashed here to create that hash. That's a blob object. And that contains, hello there, TechOne. I hope you're having a great time, which I actually do. So that's good. But what have we actually learned here? We've learned that Git has 3 basic object types. We have the commit type, the tree type, and the blob type. We know that Git will store those in its internal database, and it will utilize the hash of the object type, sort of like a pointer to the file on disk. And we've also learned that everything is just pointers and blobs, references and blobs, and Git will handle all the tooling around that. So a good way to, I think, solidify some of this newfound knowledge is to show you how this works in practice. Okay, so here we are in a terminal emulator. Nothing special. So let's start by initializing repo. Actually, before that, let's just put on a watcher. This will essentially just list all the directory listings inside of this folder, so we can keep track of the changes. So now, whenever I hit enter here, you will see changes on the right side. And yes, we saw a bunch of things happened actually. So we initialized an empty repository, and Git in turn will generate this folder for you. We have a bunch of files here, and in fact, we have a couple of them that's actually not useful. So I will remove those for the sake of keeping it pretty. So here we have a cleaned up repository, none of the default unused Git objects. So where do we start? Let's start by creating an object. So let's just type something into a file. We can see we actually created one here, and this is the base directory, so this is the directory listing here. But this doesn't actually do much because we're in a Git repository. So if we check the status of the repository, it will actually tell us we have an untracked file. So just actually, let's go ahead and add the file. Please take a note on the right hand side, try to see what happens here. When we added this file to the staging area of Git became aware of it. It started tracking it. And what that means essentially is that it will actually populate the objects directory with an object. And we know by now that this is a hash. And we can actually see the contents of this with a git command called cat file, and we will use a flag -p to actually, let's start with -t. That's a type to write this manually. Let's see. So what this tells us is that the type of the file stored in the Git document object database with that hash is a blob. We can actually print the contents of that blob with the command -p. And here we go. That's exactly what we wrote. That's the same content. So we're storing it actually in the staging area in the repository as well. So let's check the status quickly. And it tells us that we don't have any commits yet. And it actually hints at what we should do next. We should commit this file. So let's do that. Let's write some really poor commit message. So this is for educational purposes. Please be more explicit. And this generated a lot of things in the object database. So we remember that the 11EB61, that was the hash for the blob object. So it looks like it created 2 new ones. And in fact, I happen to know that one of them is a commit object and one of them is a tree object. And Git kind of helps you out here. If you look down here, when you created a commit, it will give you the prefix of the hash right there. So we can actually use the git cat file command again. And let's do t, just for the sake of it. We know that it's a commit. But what is the contents of that commit? And this is very interesting. We have some metadata here. We have, for instance, who the author is. That's me, and the committer as well. We have the commit message, and we have a tree reference. But we're missing something. I don't know if you remember that we actually had a commit reference, but this is the first commit. This doesn't actually have a parent commit, so it's omitted here. But we have this tree reference, and we saw before that we can actually cat that as well. So let's see what we get if we cat this tree reference. And this is just one line, and this here is the file permissions for this file here. So we have the file name, and we have, actually, if you realize something here, this is the exact same hash from before. So it's referencing this. Let's see what happens if we change the file. So let's echo and append it to our file. So we're changing the contents of the file. So if we print the contents, we get this now. And Git doesn't know about the change yet. So if we do git status, we will see that we have one tracked file, but it's modified. So what happens when we add this? One thing happened. It added one object to the object reference database. And can we figure out which one it was? I believe it was this one here. Yes, it was. But we're not done yet, because the status would tell us that we have it added to our staging area, but we haven't committed yet. So let's do that. And again, better commit messages, please. We actually added some new objects as well. And we can go down the rabbit hole, I think. That's probably the easiest one. Let's cat the contents of our commit. And here we see the parent commit. So in fact, the second commit will have the parent reference. So if we do the same thing here, we will get the first commit. But we were interested in this here, the tree object. And I think we realized something here. So we're referencing the same file. But if you remember from before, this is not the same blob. The first blob when we created the file TechOne.txt, this was the hash. This time it's 019FE. So it's a different file, but Git will store all the versions of your file because we have those commits. And I think an interesting thing to do here is to add a second file. So let's just echo, let's call this tech2 instead. And we add that. And commit it. And we realized this watcher here probably died there for a second, but it seems to be working now. And we have a bunch of objects here. And actually, quite a good realization can be made here. Let's just watch what happens when we cat this. So it's our third commit. We have still the same metadata as before. We have the parent. This will point towards the second commit. We have a tree object. So what did we actually do in this commit? We added one file, the tech2 file, and that's it. We didn't touch any other files. So let's see what we get when we write out the tree object for this one. We get two entries. We get the entry for tech1 and tech2. That's a bit strange. But actually, that's one of the core fundamental parts of Git. So each commit will have a complete understanding of the repository in that specific time where the commit was created. So it will actually know that when I created this commit, tech1 had this hash. It was that version. And tech2, that's a newly created one. That's that version. So I think on that note, I will leave you now, and I hope you've learned something valuable. Thank you.